Good morning, everyone, and welcome to the fourth talk of this cycle of conferences entitled Chemistry, a Hand Outstretched to Society. Our speaker today is Marta Pérez Estébanez from the Department of Painting, Conservation and Restoration, and the title of the talk is Science and Art, Research in Cultural Heritage. As a constant in my presentation of these talks, I explained that we have chosen the online format instead of face-to-face, taking advantage of the platform provided by the General Foundation of the Complutense University, to whom I want to thank the help and support to organize this activity. We thank also to our finding sources, the Spanish Biochemistry and Molecular Biology Society, the Royal Chemistry Society, Sectorial of Madrid, and Vicerrectora of Research and Transfer for their financial support, because this enables us to use this format, and this way many more people can be connected. Our junior researchers who have been investigating different aspects of the chemistry and biochemistry have returned to our institution after spending very often a long period abroad. One of the reasons we organize these webinars in English is because they are very familiar with the use of English to report their scientific research. In this way, we can broaden our audience to foreign institutions, some of which have been the host institutions for these researchers. The lectures take place on Thursday at 12:30 and will be announced every week, including the link of the registration form. During the talk, I will include the link to the 5th on October 21st in the chat. For the students who have enrolled the credits in this activity, they should email me at the address given in the announcement of this activity. Without further ado, I give the turn to the moderator of this talk, Margarita Andrés, professor of the same department and Vice-Rector of Research and Transfer of the Complutense University, who will introduce the speaker. She won't be able to stay until the end of the questions because she has an important appointment, but in her place, I will do the questions that you can write in the preguntas and respuestas button that you have in the lower side of your screen. Then now, Professor San Andrés, is your turn.
Yes, thank you very much for your introduction. Well, first of all, I would like to thank this initiative of the Vice Dean of Chemistry, because I think it's very, very interesting to share the different experience of chemistry in different fields. And in this case, Marta is going to speak about the wide link between science, experimental science in general, and in a very specific way of chemistry in the field of cultural heritage. Not only in the production of materials that are used in the cultural heritage, and also in the different procedures to a methodology applied to identify materials, to the establishment of a strategy for the conservation of cultural heritage, and the different methodologies that in fact are very, very linked to experimental science. Marta has a strong background in material science. She graduated in chemical science at the Complutense University and got her PhD at the Department of Organic Chemistry from the same university. It was in her postdoctoral stage when she decided to focus her career to the application of material science to the field of the cultural heritage. She got a position at the Center of Excellence CET in the Czech Republic, within the Laboratory of Physical Chemical Analysis of Materials. CET is an European Center of Excellence of international reputation, which was created in the period of years from 2007 until 2013, within the research program named materials, technology, and methods for the long-term conservation of cultural heritage. Most of her work there was centered on the conservation of cements and historical mortars, and she had the opportunity to make a short stay at the Córdoba University, specifically in the Department of Geoscience, for the study of historical mortars by electron backscatter diffraction. Later, in 2016, she obtained a postdoctoral fellowship at the National University of San Martin in Argentina, at the Institute of Research in Cultural Heritage, to develop her own project named Application of the Micro X-ray Diffraction and Micro-Raman Spectroscopy Techniques in Heritage Objects, which involved 3 different institutions. This institution were the University of San Martin in Argentina, the National Commission of Atomic Energy, and the Museum of Modern Art of Buenos Aires, and worked in a multidisciplinary team composed of chemists, engineers, curators, historians, archaeologists. During this period, she worked on pigments characterization within the framework of the project of the Getty Foundation of Los Angeles on concrete art in Argentina and Brest. Currently, she is a postdoctoral research in the Department of Paint and Conservation Restoration of this University of UCM, and is part of the certified laboratory LabMat. This laboratory also is linked to our research group Heritage Documentation, Conservation, and Restoration. Currently, she is involved in some of the research lines that she is going to explain in her presentation. And also, he is developing and leading her own research project about the formation and prevention of metal soaks in oil paintings. Well, I would like also to say that I hope that with her presentation is shown that the field, that the link that the scientific laboratory with the cultural heritage, with the art, and related with this question, we have our laboratory in the University of Complutense, but I want to say also that there are very, very important laboratories into important museums in Spain and abroad. For example, in this case, in Spain, is the case of the Museo del Prado, el Centro de Arte Reina Sofía, el Museo Thyssen-Bornemisza, and also and more example like this. And I think that is an interesting opportunity to share with the rest of the students and with the rest of junior researchers to know what can they do in the future into the context of cultural heritage. So thank you very much for this opportunity to show to the rest of the community, scientific community in this university, what are we doing into this context. Thank you very much. Marta, is your turn. One moment, please. I'm sorry, but I have to leave the meeting because now I have a meeting. I'm sorry very much. Marta.
Okay, thank you, Margarita, for this presentation, and thank you, Maite, for giving us this opportunity, as Margarita said, to share the work we are doing at the Laboratory of Materials. So I'm going to share my screen now. Okay, so well, as Margarita said, with this talk, we would like to give you a wide view of the scientific research that we are doing in the field of cultural heritage. But since this application field is rather unknown, I would like to make first a brief contextualization of the application of scientific methods to the conservation and restoration of cultural heritage, what is called conservation science. This discipline starts very recently at the end of the 20th century and has suffered a rapid growth in the last decades with more and more scientists involved. However, the relationship between the science and art starts much earlier. It coincides with the birth of modern chemistry in the 18th century. At this period, there was a rediscovery of the ancient world. There were found many archaeological sites like Pompeii in Italy or the ancient Egypt. And these findings needed the presence of scientists to understand what there was there. This also gave rise to the foundation of many of the modern museums like Louvre or the National Gallery. The study of heritage object or work of art includes, of course, an historical artistic documentation that gives information about the material history and the execution technique, meaning how and with what they were made, and also about the previous interventions if they were documented. Nowadays, this study also includes the scientific analysis of the materials that gives us valuable information of the material history, execution technique, and previous interventions, but also information about the state of conservation of the object and the expected degradation processes. So in order to have the whole picture of the object to study, it is needed to work in these interdisciplinary teams, including archaeologists, restorers, curators, historians, artists, together with scientists of different disciplines, such as biologists, chemists, geologists, physicists, engineers, material scientists, and what is called conservator scientist. A conservator scientist is a person, a scientist that is used to work in the field of cultural heritage, so knows the problems that the restorers may have and the kind of samples they work with, and also has a common language with them that is not always easy. But besides the study of the composition and properties of historic materials, the scientist working in cultural heritage also contributes to the development of new materials and to the optimization of analytical techniques. These are the reasons of the existence of our laboratory, the Laboratory of Materials at the Faculty of Fine Arts of the Complutense University. This lab was created in 2004 by the initiative of our research group, Heritage Documentation, Conservation and Restoration Techniques. It is part of the Laboratory and Infrastructure Network of Madrid, and we are very proud to work under the quality standard 9001. We are one of the few labs dedicated to cultural heritage that work with this quality standard. And it is, we think, really interesting because it covers not only our analytical procedures, but also the conservation of the samples that in some cases, they are very valuable samples. This is our research group. It's an interdisciplinary team, as I explained, is needed, and it includes conservators, restorers, historians, archaeologists, chemists, and biochemists. Our research is divided or follows 4 different lines. First of all, the study of new materials used in conservation and restoration, mainly synthetic polymeric materials. Then the study of pictorial materials and techniques, the study of materials degradation and deterioration, and the study of the efficacy of restoration treatments. Of course, we don't work alone. we have several collaborations. We work with the Institute of Geoscience, IGEO, that is a mixed institute belonging to both the Complutense University and CSIC. We work with the Institute of the Spanish Cultural Heritage, belonging to the Ministry of Culture, with the Laboratory of Polymers Technology of the University Rey Juan Carlos, the Palarc Foundation and Guarrazar Archaeological Sites in Toledo, the Center of Excellence Delch, belonging to the Czech Academy of Science, the Institute of Research on Cultural Heritage of the National University of San Martin in Buenos Aires, and the Research Center for Colloids and Nanoscience of the Florence University. So now I'm going to briefly show you 4 works that follows these research lines. In some of these works I'm directly involved, in some others I'm not, but I'll do my best to show you the variety of research works we are developing. First of all is the physicochemical studies of synthetic polymeric materials and their use in conservation and restoration of cultural heritage. This research line is has the longest trajectory and have given rise to 2 PhD theses and several research projects. But why to study synthetic polymers? Well, there has been a fast evolution of new materials and new treatments that are applied in conservation and restoration, but also materials that are used directly in the artistic creation. These materials include great variety of synthetic polymers, processing methods, and additives which modify their properties. But all of them were developed for different uses than that of conservation and restoration. In some cases, they are in direct contact with the works of art and heritage objects, and in some other they are directly part of the works of art. And in many cases, in most of the cases, I would say, conservators and artists don't know the properties and the risk of the use of this kind of materials. So there is a need of knowing their chemical composition to study the long-term behavior and evaluate their stability. The materials we are studying are divided in 3 groups. Those used in curative conservation, that means in restoration, that can be permanent or temporary. And these kind of materials are, for example, adhesive, consolidants, coatings, rubbers, or sponges for cleaning. Then materials used in preventing conservation, it is in the transport, storage, or exhibition, and can be used as protective, as support, or thermal or ball isolators. And most recently, we have added the study of polymers used in 3D printing, since these materials are used in artistic creation, but also in the conservation of cultural heritage. The methodology of study is very simple. The selected materials are fully characterized. We are interested in the chemical composition, both from the polymer matrix and from the additives. And we use FTIR, pyrolysis, gas chromatography, mass spectroscopy, and thermogravimetric analysis. We're also interested in their morphology. It's really important in the materials that are, for example, fibers or tissue, non-tissue, and we use optical and scanning electron microscopy. We study also some physical properties such as crystallinity, glass transition temperature, color, using spectrophotocolorimetry or DCC. and mechanical properties using dynamometer and GBC. The materials, once characterized, are conducted to a process of accelerated aging and then characterized again using the same techniques. The accelerated aging follows normalized procedures that are perfectly described in some standards. We conduct aging under different radiation using arcoxenon lamps, which reproduce the damage caused by the sun, or ultraviolet light, which is in fact the most harmful radiation. We also do aging experiments under different environmental conditions of temperature and humidity, or under constant temperature. What we do is we follow the physical-chemical changes that are occurring with the time of exposure. Following this procedure, we have analyzed a great variety of commercial materials that are used in conservation and restoration, and have created a database that is available and try to be of help for conservators when they need to choose a material. This website is held in the website of the Ministry of Culture. I would like to show you. And include information about the project, the work team, that as you see is a very large team. This work was made from a collaboration of our research group with people from the Institute of the Spanish Cultural Heritage. It contains also information about the techniques and protocols, the project, and all the materials studied. Every material includes a file, and I can show you one example. Yeah, this is one example, and for each material, there's information about the chemical composition, the aspect and fabrication, and some techniques, technical characteristics, and general characteristics given by the producer. Information about the application in conservation and restoration, and environmental impact, and all the results obtained from the analysis, both before the accelerated aging, the conditions of this aging conducted under radiation and environmental conditions, and all the results obtained after this aging, with some short conclusions at the end about the stability and some bibliography, of course. Following this procedure, we have analyzed also other kinds of materials that are more complex, that are the supports used for mounting large format photographies and digital prints. These are multi-layer materials with an inner part of polymeric material and outer part of cellulose or sometimes metallic materials, and containing also adhesives. These adhesives can also affect the stability of the photographies, since in many cases there is an emission of acetic acid. So we decided to study also the effect of these volatile organic compounds that can be emitted by putting together the support color reference some pH stripes, and a collection tube for these organic compounds that were sealed on using marble seal bags. This procedure is useful not only for the analysis of adhesives, but for all the polymeric materials that are emitting these volatile organic compounds. Well, the next work I'm going to tell you is the youngest research line in the lab, deal with the formation and probation of metal soaps in oil paints. Metal soaps were first discovered at the end of the 1990s when curators of the Murid-Huis museums discovered small craters, and together with whitish protrusions formed at the surface of this painting, the anatomy lesson of Dr. Nicolas Palt. And these craters were formed as a consequence of the reaction between the binder and the pigment. Since this reaction is a saponification, they decided to call them metal soaps. Since then, curators of other museums all around the world found similar features in paintings for different periods. Most of the metal soaps were found in oil paintings, which contain metals such as lead or zinc. The drying oils are formed by triglycerides of unsaturated fatty acids such as oleic, linoleic, and linolenic fatty acids that are the most frequent, that form a polymeric network, giving rise to a rigid and solid film. This film, the esters of this polymeric network can react and give rise to carboxylic acids through two different mechanisms, the mechanism of hydrolysis and the mechanism of auto-oxidation. And these carboxylic acids can form complexes with metals from the pigments, first within the polymeric network, but forming amorphous metal soaps that can eventually crystallize. Here we can see how the formation of metal soaps in an intermediate layer of a painting, that the nucleus of metal soap start growing and then produce a crack and finally a protrusion on the surface of the painting. And here we can see how this protrusion looks like in a real sample under the optical and the scanning electron microscope. This degradation mechanism is intrinsic to the painting, since it's the reaction of two of the components of the painting. So the only strategy that can be adopted is a strategy of preventive conservation. That means trying to avoid or at least reduce or slow down this reaction by keeping the painting safe. These have given rise to a great number of research works, and it has been discovered in the last years that this process is strongly affected by the environmental conditions of temperature and humidity. But in all these works, they consider stable conditions that are not the ones that normally can be found in museums, art galleries, or of course the artist studio. So that's why we decided to study the effect of variable humidity on the formation of metal soaps. To the same, we selected 4 different pigments, 2 of them containing lead, that is the lead white and medium, and 2 containing zinc white and litopon, and 2 different drying oils, the linseed and nut oil. We prepared the paintings, mixing the proper amount of pigment and drying oil, and do painting films spread on a polymeric surface. These films were dried for 4 days at 60 degrees, and we consider this our time 0 of the study. So the paintings were then subjected to different conditions of relative humidity, low values between 30 and 50%, both variable and stable, high values between 50 and 70%, also both variable and stable. And then we decided to use also what we call the standard condition, that means 21 degrees and 55% of relative humidity, that are the condition you found in some museums or storage rooms. And we had a study of the behavior of the paintings under uncontrolled conditions, that means in laboratory conditions. The total curing time is 16 weeks. And the chemical and physical changes that occurs during curing are recorded. We identify we can detect the formation of metal carboxylate using FTIR. We can identify those carboxylates using gas chromatography mass spectroscopy. We are also recording the degradation of the painting by X-ray diffraction, and we are observing the surface of the paintings with by the microscope using visible and ultraviolet light in order to see the formation of these deterioration features on the surface. Samples are also observed on in cross-section using optical microscope and SEM with backscatter electrons. This work generates a huge amount of data. We are now, we have finished the first half of the experimental procedure. So we still don't have conclusive results, but we have observed so far that the paintings containing medium and zinc white form metal carboxylate during the drying that can be seen in the FTIR spectra with this broad band here that is growing with time. We have observed also that low relative humidity conditions promote the formation of metal carboxylates during the first 6 weeks, since this band keeps increasing. And this is showing or is suggesting that the mechanism of formation of carboxylate acid is an oxidation mechanism rather than an hydrolysis mechanism, which would be favored by the high relative humidity. In fact, the high relative humidity produce that water molecules occupy the free volume of the surface and limits the oxygen diffusion. As I said, these are our preliminary results. We are working now on trying to understand what the variation of humidity can be affecting this mechanism. Next research is the work of a PhD thesis about the study of color lacquers and their color variation related to the physicochemical preparation parameters. The color lacquers are color products made of dye precipitated on inner material or a substrate and giving rise to an insoluble substance similar to a pigment, but usually showing a higher transparency. Their use goes back to ancient times, up to the 19th century, when they were substituted by synthetic dyes. They were used in many cases for clothes due to their increased transparency, as we can see here in this Santa Catalina by Carballo, where the scientific study showed that these blue clothes were originally red, painted by a red lacquer, but later on it was decided that the sheet should be wearing blue. There are many kinds of lacquers. In this work we decided to focus on two red lacquers, the cochineal and madder root. And the first step of this work was to collect the ancient recipes for the preparation of this kind of compounds. In the case of the cochineal lacquer, 4 recipes were selected from the 16th to the 19th century. At this time, the knowledge of the preparation of this kind of pigments were held by painters, not by scientists. So the procedure here described are more similar to the cooking or alchemy procedure, not chemistry procedure. So it was necessary to translate these recipes into a chemical parameters. The use of these 4 different recipes gave rise to pigments with different colorations. And in this cochineal lacquer, the responsible of the color is the carminic acid, which contains hydroxylic groups. So this make it reactive with the pH. So the difference between the procedure described in these different documents are the pH values used. So we decided to reproduce these procedures and study the parameter of pH. In the case of the madder root, there were selected 2 different procedures from the 19th century. One of them uses a high temperature and the other is a cold procedure. In the case of this pigment, the responsible of the color are the alizarin and purpurine compounds that are formed through enzymatic reactions. These reactions are sensitive to the temperature and the time, and the ratio between the alizarin and purpurine is changing, as can be seen with liquid chromatography. So we decided here to study the temperature and time as synthesis parameters. Once the lacquers were prepared, varying pH values in the cochineal and temperature and time in the madder roots, they were agglutinate using different binders, drying oils, egg yolk, and gum arabic, and make painting films. These were studied by spectrophotocolorimetry to obtain their reflectance curves and CLAB color values. And they were also observed with ultraviolet light. It was interesting to notice that the paintings with similar color values, like these 2 here that are, these 2 here that are madder lac with linseed oil prepared and cold procedure and with temperature, they were much easier to distinguish using the ultraviolet light due to their different fluorescence, as can be seen here. So this can be a way to obtain information about the different preparation procedures in historical materials. Finally, I would like to talk to you about the other PhD thesis that is focused on the evaluation of new cleaning treatments to remove insoluble salt deposits in archaeological ceramics. Archaeological ceramics are very interesting objects since they contain very relevant information about the past, and they are very abundant in archaeological sites. This is, among other reasons, due to the high physico-chemical resistance. However, they sometimes can be found covered by a calcareous deposit, which may hide some of important information about the objects. This work started with a survey that was made to museums, university and research centers, and also to conservators or restorators that are freelancers, about the products and application methods they were using to remove these calcareous deposits. We found that the most used products were chelating agents and acid solutions applied by a direct method, that means by immersion. And we notice also that in many cases the restorers don't know what this kind of methods can, how they can affect to the archaeological ceramics. So we decided to develop new cleaning treatments and evaluate both their efficacy in the removal of the deposits, but also their safety. So we started preparing model samples from a commercial clay that was modeled, cutted and dried, and then fired at different temperatures in the range of 650 and 1100, which is the temperature range of usually found in the archaeological ceramics. These model samples were fully characterized, and we analyzed chemical and mineralogical composition using X-ray diffraction, SEM EDX, and thermogravimetry, and some of the physical properties such as surface morphology with microphotography, roughness and SEM, the porosity with saturation tests, and color using spectrophotometry. The next step was to grow a calcareous deposit. So the surface was covered with a mixture of lime putty and soil, and then treated in a carbonation chamber during 10 days using a concentration of CO2 of 1600 ppm to obtain a calcareous deposit that will be then cleaned. The cleaning treatments used follow the criteria of maintaining a constant pH, using the minimal concentration of the cleaning agents and during the minimum time. The cleaning agents used were two acids, one a strong acid, the nitric, and a weak acid, the acetic acid, and one chelated agent, the EDTA. And the application methods was direct by immersion and the indirect using different kinds of gels that allow a bigger control of the cleaning procedure. Here you can see the samples cleaned by immersion using nitric and acetic acids, and both treatments were apparently successful, but the samples need to be studied using the characterization techniques employed before. And this allowed us to evaluate their efficacy in the amount of calcium carbonate they were able to remove, and their safety in the changes of their physical and chemical properties. The next step is the application of such cleaning treatments on real pieces. So we started a collaboration with the Palark Foundation to analyze some ceramic materials found in the Huarrazar archaeological site. Real pieces show different problems from the model samples. For example, sometimes they show fabrication marks, like in this case here. This is giving valuable information about this object, so need to be kept during the cleaning treatment. In other cases, we can find use marks, like in this case here, that is also need to be kept. And here we can see this black crust that is indicating that these ceramics were probably used for cooking. So these are some of the works we are developing in the lab. I hope I was able to transmit you the great variety of topics and the contribution that science can make on the study of cultural heritage. Thank you very much for your attention, and I will be glad to answer your questions.
Thank you very much, Marta, for your nice presentation. I think that it's very important to know that the chemistry, it's relevant for any kind of fields. I mean, here is a field in which we are not familiarized, but I think that it's very, very nice to see how many techniques do you use and for many applications. Then I think that thank you very much. Well, I think that there are one question. Sara Garcia Linares is asking that in terms of accelerated agent studies, is it possible to consider the effect of wind in some way?
Yes, well, we are not doing that at our laboratory, but there are other places where it is possible. In fact, in the Center of Excellence Delft, where I made my first postdoc stay, they have this climatic chamber with a wind tunnel. They were studying, well, not only materials, but there were a lot of architects and engineers there. So they were studying also how the wind is affecting the material and the structure of the buildings. Yes. And of course, it can be, wind can be produced using different environmental conditions, like rain, of course, and the presence of different contaminants, etc., etc. So the accelerating aging, you can make almost everything you want.
Okay, thank you. And Sarah has another question. She asked how fluent is the communication collaboration between your research group, for example, an artist or curators from museums, for instance. And also she asked that if you have particular requested for them.
Well, we are dealing with artists and restorators all the time. We try to understand their problems so we can focus our research, because our work is trying to help them. So it is very important that we have this fluent conversation. Sometimes it's true that it's not easy because we are talking different languages. No, there is this separation between the humanities and science since the basic education that makes sometimes really difficult. But that's the reason why it is needed to have scientists specialized in conservation of cultural heritage, because of course for scientists of other disciplines it is even harder to have this conversation. We have to teach the students. They have 3 subjects in the degree of conservation and restorations with a strong scientific character. And well, they have to struggle with these subjects, but I think it's needed that they have this background to be able to then communicate with us, of course.
And when she asked also if you have some particular, you have got some particular requests for these artists or curators. I don't know if you have some particular.
I don't know what you mean. If I have, they ask us some particular
Work
experiment or work.
Yeah, work.
Yes, of course, yes. Well,
for instance, I have a question in this sense. You also participate in, for instance, to know if one piece of art is false or not, or is, I mean, or has some kind of manipulations. That you...
Yeah, we can work. I didn't do it personally, but our lab was involved in different works. In which they discovered like that the authorship of a work of art was different from what was believed. For example, the analysis of a pigment that can be done using different techniques, as I showed you, can indicate the period of time in which this paint was produced. So it can help to the authorship of a work of art, of course. We have also some requests. Recently, we have a request of an artist that is working with pens, and he was interested in knowing which of the pens that he can find produce the most stable ink. So we made some accelerated aging studies, and we can help him to select the kind of pen and the kind of paper he need to use to make their works more stable in time.
Okay, thank you. Well, there are no more questions, but I have more. Something about the background of the people that is involved in this kind of work. No, it's for the students. It is better to study some background, scientific background, and also try to get some kind of master of humanities, for instance. So it's better to study humanities and after to try to connect with the techniques in science. I don't know which is your opinion. If you have someone.
Yeah, well, I think both approaches are good, and the work they will be able to do is a bit different, at least at the beginning. No, when you have a strong background in science and then you start to work in cultural heritage, of course, you need to study a lot about history, arts, etc., to have this common language. So there are some master programs in the Faculty of Fine Arts. There is this master program on conservation of cultural heritage. And there are students from scientific degrees, but also from humanities as conservation and history, etc. And other universities here in Spain and in other countries offer similar master programs. When you have background in the humanities and conservation and restoration, you will need to work and you want to approach this kind of research, you will need to work with a scientist, because although they study several techniques, the most used techniques in this field, they are not able to conduct experiments and treat the data. So they need to work together with a scientist, but they are more aware of the real problems they can found during the intervention of a work. So they can figure out more easily the research lines that are interesting in this field. So, well, I think it is good that we all work together, of course.
Okay, thank you. And I have another question too. When you, for instance, when you established some kind of cleaning procedure or some kind of treatment for any, I mean, for this kind of work that you have done, I mean, you have to patent this kind of methods, or it's or you have some kind of standardization of this method that you test in the lab?
Mm-hmm. Well, normally not the methodology, but the products are normally patented. For example, the gels used in the cleaning treatments are patented, so they can then be commercialized. But the cleaning procedures, as far as I know, they are learned at school and during the work. Yeah.
Okay. Well, Marta, I thank a lot, because I think that, well, it was very, very bright talk. We learned a lot of things, and I suppose that many people are going to thinking in questions, and maybe they can ask you if they have time in the future. And this can be a good point for establish some kind of collaboration between our departments. I know that you work also with some people from here, from the chemistry faculty, I think. Remember that? Then I thanks a lot, and well, okay.
Thank you.
I say, well, everybody, if somebody have a question, last question. If no, we can close the talk. And thank you very much.
Okay, thank you very much, Maite. I'm very happy to be here, and I'm glad that, well, as I said, that this kind of work is spread. And we are at the Faculty of Fine Arts, where you can visit us, and of course contact me with any other questions.
Yeah, I encourage everybody to go there, because you have a very nice exposition also about different materials, different colors, natural pigments, and different colors from them, obtained from them. And I think that it's a nice thing to view. And I think that everybody can go there and see
everybody is welcome
that you have.
Yeah.
Okay, thank you, Marta.
Thank you very much. Bye-bye.